Good day, everyone. Today we are going to look at Module 5, non-concurrent forces. Okay, the way I'm going to explain this topic is by just using an example that is in your textbook. So I'll take example 2 because I think it has more things to talk about. Okay, so you see here we have a horizontal bar. Here they say this is a horizontal bar. So a window cleaner stands on a plank suspended. So I'm reading the example from your textbook. Stands on a plank suspended by two ropes attached at either end and at the plank. The mass of the cleaner is 60 kgs and that of the plank is 15 kgs. The cleaner stands at a distance of 0.7, so this is the distance, meters from one end of the plank, which is 3 meters long, and determine the tension in each of the ropes. So the one has to determine the tension T2 and the tension T1 here. So as you can see, this is a regular plank. So as you can see, it's a perfect rectangle. So we have the tension, we have tension 1, we have tension 2. We are also told of the weight of the cleaner, which is this part. So we also need to include the weight of the plank. And as you can see here, it has been put in the center, which is a convenient place to put it, since it is since we can take it as the center of mass of this plank. Why do we take it? Why do we take the center as the center of mass? Because this is a regular plank. It has, this side is equal to that side, so we'll take the center here as the center of mass. So but by definition, the center of mass is the point at which the gravitational force acts on. And for our calculations, for convenience, we usually put it at the center of the object. Okay, so now we need to calculate these tensions T2 and T1. So to calculate these tensions, we want to ensure that this particular plank is in equilibrium. All right, so how do we ensure that? So to ensure that it's in equilibrium, what we are actually saying is that this plank is not moving up, nor is it moving downwards. So what do we mean that? So what do we mean by that? So by that, we would simply mean that the summation of horizontal forces should all equal to 0, because we are saying this plank is not moving up or down. So that's equilibrium if the upward forces are equal to the downward forces. And then another thing is this plank is not moving to the right, nor is it moving to the left. So to do that, how do we do that? We say summation of horizontal forces should equal to 0. Okay, like this. And this is to ensure equilibrium of the plank. So I usually take upward forces, so forces pointing upwards, as positive, and forces going downwards as negative. But it's your choice, as long as you are consistent with your direction. So I take upward forces as positive. And then here I usually take forces to the right as positive. Okay, so as you can see in this question, if we just take these situations, we will not be able to calculate T1 and T2, because we say T2 plus T1 minus 150 minus 600. We will still have these two unknowns, T2 and T1, because we cannot solve. We'll only find T2 plus T1 is equals to 750, but still we have not solved T2 and T1. So another condition that we need to use is the condition of moments of a force. So moments of a force, or torque of a force. So because these non-concurrent forces also can cause an object to rotate. So in this instant, T1 can cause this object to rotate in this direction because it is pointing in that. And then T2 in turn can cause this object to rotate in this way. And then so T1 can cause it to rotate about this center part, which we can call as the pivot P. But for this specific question, I do not want us to take the center part as the pivot. I want us to take T2 instead as the pivot. Why are we doing this? Because by taking this point here where T2 is as the pivot, we get to eliminate T2 from the equation. Because our equation for moments would be, so we would have an equation like this. So we'd have summation of, or it's torque as well. So, but this is torque at T2. So we'd say this. So now we'd have, so for me, I usually take anti-clockwise moments as positive, but the textbook uses a different, takes clockwise moments as positive, but it's still the same, it gives the same answer. So here we would say T1 times 3, because 3 is the distance between T1 and the pivot. So T1 is here and then the pivot is here 3 meters away. So this distance, we know it's 3 meters, this whole distance. So T1 plus 3, because I took this direction as positive, so it means this direction, because as you can see, this force tends to make this go that way, and then same with that force, it tends to make this thing go this way, considering P as the pivot. So so now we would have minus 600 times, so this distance would be 2.3 minus 150 times, this distance is 1.5, is equal to 0. And this way we can see we only have one unknown, which is T1 here. And after solving this and that, so this is 750, this is 1380, I think. This 1380 plus 750, you take it that side, you divide by 3, you can easily calculate T1. Once you have calculated T1, you can use this equation here to calculate T2. But this is another method which is a bit different from the one in the textbook, but still they both give the same answer. Okay, so basically this is the summary of module 5. If you have any questions, do send me a message. Thank you very much.